This is section 2.8, the algebra of functions. So the first thing we're going to talk about is the operations on functions. And it's pretty much what you think it might be. We have this new function called f plus g of x, and it's simply f of x plus g of x. Likewise, f minus g of x is simply f of x minus g of x. And f times g of x is just f of x times g of x. And it's the same thing for the quotient of x. It's f of x divided by g of x. But we do have to make sure that g of x is not equal to 0, or we would have a function that is undefined. So let's begin. We're given function definitions for f of x, g of x, and h of x. We have a quadratic function for f of x, we have a root function for g of x, and we have a quotient function for h of x, or a rational function. So let's first find f of -3. So here we will use the function definition given for f of x, and we just have -3 squared minus 3 times -3 plus 1. Let's go ahead and move that down here. And that's equal to 9 minus 9 plus 1. And we have 9 plus 9 plus 1. And that's 19. Okay, g of 4. So we're going to use g of x. So g of 4 is equal to the square root of 8 minus 4. That's the square root of 4. And that's equal to 2. We have f of a plus 1, and that's equal to, so we're going to use f again. A plus 1 all squared minus 3 times a plus 1 plus 1. Let's go ahead and first find a plus 1 squared here. So a plus 1 all squared is a plus 1 multiplied by a plus 1, and that's a squared plus 2a plus 1. So there's 1a and 2a for the outer and the inner. Okay, so that comes out to be a squared plus 2a plus 1. Now we'll distribute the -3, and we will combine like terms. Here are a terms, and here are our constant terms. So this is equal to a squared minus a minus 1. Okay, g of 10, we'll be using the definition for g again. That's equal to the square root of 8 minus 10. That's equal to the square root of 2. And that is undefined, and that is not a real number. We could also write that. Okay, so f minus g of -8. So we just learned that definition, f minus g. So that's simply equal to f of -8 minus g of -8, okay? So let's find f of -8 first, and that's -8 squared minus 3 times -8 plus 1. And then now we're going to subtract g of -8, which is 8 minus -8, all under the square root. And let me just write that as a normal minus, and then I'll highlight that so you know that's where g of -8 begins. And we have 64 plus 24 plus 1 minus the square root of 16. And if you add all of that up, you will come up with 85. Okay. and that's 89 minus 4. Okay, g times h of 0, that's g of 0 times h of 0. And if you can see our function definition for g, that's the square root of 8 minus 0. And then h of 0 is 2 divided by 0 plus 1. So that is equal to the square root of 8 times 2, which is equal to 2 root 8, and that is 4 root 2. And that square root of 8 is 2 root 2. Okay, taking a look at number 7, h of negative 1. So h of negative 1 is 2 divided by negative 1 plus 1. That's 2 divided by 0, and that is undefined. Okay, now let's write the domain in interval notation for each one of these operations. So we'll go ahead and begin with r minus t of x. That's defined as r of x minus t of x, and that's equal to x squared plus 3. And now let's subtract t of x, which is x plus 4. Now we will have to distribute that negative sign because we're subtracting all of t of x, and it's equal to x squared minus x minus 1. And the domain of, and they talked about the domain here for each one of these. It would be the domain that is included for each individual function, except we just have to make sure g of x is not equal to 0. And in this case, the domain is going to be all reals. That's a quadratic function, and both r and t were polynomials. Okay, so now let's take a look at r divided by t of x. That's defined as r of x divided by t of x, and that's equal to x squared plus 3 divided by x plus 4. Now, as you can see, x plus 4 cannot equal 0, so x cannot equal negative 4. So our domain is going to be all real numbers with x not equal to negative 4. Okay, let me move this. Okay. So this domain is going to be negative infinity all the way to negative 4, going over the other side of negative 4 and all the way to infinity. Okay? And we could have started with the domain of each one of these because the domain of t of x and r of x are all reals. In the domain of s of x, we can't have x equal to 0. So that's worth pointing out when we get here to number 10. S times t of x is s of x multiplied by t of x, and that's equal to 2 divided by x multiplied by x plus 4, and we end up with 2 times x plus 4 all over x. And we can rewrite that as 2x plus 8 all over x. Keep in mind here, x cannot be equal to 0, so our domain will be from negative infinity to 0, going on the other side of 0 all the way to infinity. Okay, let's talk about something called a difference quotient. And basically, a difference quotient is the average rate of change between 2 points. And it is, for example, the slope of the line between those 2 points. Okay? And so we define the difference quotient as this: f of x plus h minus f of x, all divided by h. And we're going to talk about how this works. But basically, h is this distance, this horizontal distance between those x values. And that's where this h comes from, okay? Okay, find f of x plus h and then find the difference quotient for f of x equals 5x minus 2. So what I like to do is I like to first go ahead and find f of x plus h first. Okay, so f of x plus h is equal to 5 times x plus h minus 2. As you can see, our x is x plus h. And that's equal to 5x plus 5h minus 2. So now we're going to use the difference quotient. And we're going to have f of x plus h minus f of x all over h. And again, this is our f of x plus h. So that is equal to 5x plus 5h minus 2. Now we're going to subtract f of x, which is 5x minus 2. And then we're going to divide all of that by h. So that's equal to 5x plus 5h minus 2 minus 5x plus 10x minus 5x plus 4. My goodness. All over h. So as you can see, our 5x's cancel. And we end up with 5, and this should be a plus 2. And those will also cancel. So this works out really nice. 5h over h, and it's simply equal to 5. Okay, let's look at number 12. Again, I always like to find f of x plus h first, and then I will plug this into the difference quotient. So f of x plus h is equal to x plus h all squared minus 3 times x plus h plus 8. Now we're going to square this binomial first. That's x squared plus 2xh plus h squared. So a little practice multiplying those binomials. And let's distribute that 3. And this is what we have. So there's not much that we can really simplify with this yet. All of the terms are different. But now let's go ahead and use our difference quotient. And I think I'll use a darker pen. So we have f of x plus h minus f of x all over h. So f of x plus h, remember, is all of this. So that's equal to x squared plus 2xh plus h squared minus 3x minus 3h plus 8. Now we can't forget about our minus here. Minus, and now we're going to subtract all of f of x. So we will distribute that negative at the very end to both of those, to all three terms. Minus x squared plus 3x minus 8 all over h. So let's see what we have. X squared minus x squared. Negative 3x. Positive 3x. Positive 8, negative 8. I will give you a little hint. Do you see that every term remaining has an h in it? That's when you know that you've simplified correctly, because we will end up canceling that h out. So we're going to divide each term by h, or you could factor out an h in that numerator if you'd like to see it a little better. And then these h's cancel, and we finally get, move this just up a touch, and we finally get 2x plus h minus 3. Okay, now we're going to talk about the composition of functions. So composing and decomposing functions. And this is, again, a definition that we will use. So the composition of f and g, and it's denoted f composed with g. It is not a closed circle. It is not a big circle. It is just a small open circle, okay? So the definition of f composed with g of x is f of g of x. So g of x becomes the input of f of x. So we have a function inside of a function. Let's give it a try. So we have f composed with g of x, and that's defined as f of x. Excuse me. Let's use our definition right here, f composed with g of x. It's defined as f of g of x, and that's f of, and I'm going to put g of x in a different color, 5x plus 4. So what do you notice? 5x plus 4 is going into the function f. Everywhere there is an x, we are going to put 5x plus 4. So we have 5x plus 4 all squared minus 3 times 5x plus 4 plus 1. Okay, and we're going to go ahead and square this binomial. If you need to go somewhere else and do that, to square this binomial, we have 25x squared plus 40x, that's 20x times 2, plus 16. Let's distribute that negative 3, and we still have that plus 1. And that will simplify 25x squared, and here are our x terms, and here are our constants. So we have 15x, no, that would be 25x, and then 16 minus 12 plus 1 is 5. Okay, let's try g composed with f of x. That's equal to g of f of x. So now we're going to go to the g function, and everywhere there is an x, we're going to have x squared minus 3x plus 1. So this is going in for that x. Okay? So that's equal to 5 times x squared minus 3x plus 1. And don't forget about that, plus 4. Distributing that 5. And we have two like terms. And we end up with 5x squared minus 15x plus 9. Okay, let's try this next problem. F of x is a quadratic function, 5x squared minus 1, and g of x is given as the root of 5x plus 5. We are looking for f composed with g of x, and that's defined as f of g of x. And that's equal to f of root 5x plus 5. So everywhere there is an x in f of x, we are going to put root 5x plus 5. So we have 5 times root 5x plus 5 all squared minus 1. And that's just 5x plus 5 minus 1. And that's 25x plus 25 minus 1. And we come up with 25x plus 24. Okay. Let's look at g composed with f of x. And you can clearly see that f composed with g of x is not equal to g composed with f of x. So this is defined as g of f of x, and that's equal to g of 5x squared minus 1. So everywhere there's an x in g, we're going to put 5x squared minus 1. So that's equal to the square root of 5 times 5x squared minus 1 plus 5. And that's equal to the square root of 25x squared minus 5 plus 5. And we end up with the square root of 25x squared. And as you can remember, the square root of 25 is 5, and the square root of x squared is the absolute value of x. Okay, let's give number 15 a try. So we have something a little bit different here. Notice that we are composing functions at values of x, as opposed to composing functions with x as a variable, okay? So it is a little bit different, but we're not going to change our method. So we have that f composed with g of 9 is f of g of 9. So the first thing we want to do is we want to go find g of 9. So I'm going to go down here and I'm going to find g of 9. And that's 2 times 9 minus 8, and that's equal to 10. So now I'm going to find f of 10. And that's equal to 3 divided by 10 minus 4, 3 divided by 6, and that's equal to a half. Okay? And I'll just highlight g of 9 and g of 9. Okay? Now let's find g composed with f of 6. And again, we'll go somewhere else on our paper and we will find f of 6, and that's equal to 3 divided by 6 minus 2, and that's equal to, 6 minus 4, and that's 3/2. So now we will be finding g of 3/2. And that's equal to, the g function takes 2 times 3/2 and then subtracts 8. So we have 3 minus 8, and that's equal to -5. Okay, now we're going to talk about the domain and range of these composite functions, okay? And what I always like to do is I always like to talk about the inside. So when we're talking about the domain of a composed function, we need to consider the inside function and the new function's domain. Okay? So we need to consider those domains. Okay? So let's first find the domain of f composed with g of x. And this is not one of the examples that we have done above, so we're going to have to find these compositions first. But a lot of times you'll find them and find the compositions and then the domain along with them. So let's go ahead and first find f composed with g of x. That is this composite function, and that is f of 3x minus 2, and that is equal to 3 over 3x minus 2 plus 2. Don't forget about that plus. And that's equal to 3 divided by 3x, or 3 divided by x. Okay. Excuse me, 1 over x. Okay, so this is f composed with g of x. I was thinking we had to find both of these, and I sort of crowded this. But now let's talk about the domain of the inside function. Our inside function is g of x. That is a linear function, polynomial. That domain is all reals. And our new function is 1 over x. This is our new function, and x cannot be equal to 0. So the combination of both of those is negative infinity, going all the way to 0, going on the other side of 0, all the way to infinity. Okay, so we did not have to worry about the domain of f. We did not have to worry about that because we are going to talk about the domain of the inside and the new function when we give this final domain, okay? Okay, so let's go ahead and now look at h of x that is the already composed function. So what I like to do is I like to say what the inside function is and what the outside function is. So can you see that the inside function is going to be, we could say g of x is equal to 3x minus 7, because this is equal to f of g of x. This is the inside function, and f is the outside function. So the outside function we're going to call f of x, and it's simply the square root of x, what is input, okay? So that would mean that f composed with g of x is going to be f with g of x on the inside, the square root of 3x minus 7. Most students think these are kind of fun. So what do you notice? This is our inside function, and our inside function is going to be g of x, and our outside function is this cube plus 8. So that would be, let's go ahead and define g of x is x plus 1, and that outside function is going to take that input and cube it, and then add 8 to it. So this is now f of g of x is x plus 1 all cubed plus 8. Now let's find some composite functions from the graph. Keep in mind that f and g are both given here. So there's two different graphs. We need to write our definition first. So this is equal to f of 3 minus g of 3, and f is the blue graph, so f of 3 is going to be 4, and g of 3 is going to be 3, and we get 1. Okay, this is equal to this quotient function g of negative 2 divided by f of negative 2, and g of negative 2 is negative 4, and f of negative 2 is 2. And negative 4 divided by 2 is negative 2. Okay. How about g of f of 1? So I'll give you a hint on these. I always suggest students going and finding f of 1 first. So let's go to the graph. When x is 1, f is the blue function. They actually have the same value there. Y is 2. So now we're going to find g of 2, and that will be 4. Okay? So make sure you find that inside function first when you're composing at a value. Okay? So this is equal to f of g of negative 3. We're going to find g of negative 3 first. So when we go to the graph, we have g at negative 3 is going to be negative 4. And now we'll go to f of negative 4, and that looks like it's going to be negative 2. And our last one, we have a function composed with itself, but what's the good news? We're not going to change our formula. We're going to first find what f of negative 3 is. And going to the graph, f is the blue function, and f of negative 3 is 0. And so now we're going to go find f of 0, and that's equal to 2. Coming up to our last page in this very long section, we have a party balloon, and it's being filled with helium. And as the balloon is filling, the radius of the balloon is changing at a rate of 3 inches per second. Okay? So let's go ahead and let t equal time. Okay? So if we let t equals time in seconds, what would we have as far as the function goes for this radius of the balloon? we could call that r of t. That's what they've asked us. After t seconds, we would have 3, which is 3 inches per second, multiplied by t. So you would have inches per second multiplied by second, and you will have inches of that radius. So that's where we get that. Okay. Now, write a function that expresses the volume of the balloon as a function of the radius. Well, this is just a formula that you may or may not know, but the volume in terms of the radius of any sphere is 4/3 pi r cubed. Okay, and this is the formula for volume of a sphere. So now they would like us to compose the volume and the radius functions. So here we will have v of r of t, and that's v of 3t, and that's equal to 4/3 pi times 3t cubed, and that's equal to 4/3 pi times 27t cubed, and we have 4/3 times 27 times pi t cubed. And we can reduce this with a 9, and we can end up with 36 pi t cubed. And it wants us to interpret this meaning. And so basically, this function, v composed with r of t, is the volume of the balloon at time t. You can see the t here. Okay, now they've asked us to evaluate v composed with r of 2. So keep in mind, this is going to be the volume of the balloon after 2 seconds. So this is v of r of 2. And we just found that formula. We don't have to do it again. That's equal to 36 pi times t cubed. And that's equal to 288 pi. So you can put that in your calculator and you'll get about 904.32 inches cubed. Okay, and let me kind of show you where pi is on your calculator, and also show you how to type 36 times 2 cubed, and you'll get 288. And I want to multiply that by pi, and pi is right above the arrow up, and you'll get 904 point, and I guess that should have been, maybe we did 3.14 and not the exact. I meant 3.14 times 288. I think that's where I got the 904.32. Let me just write that down real quick. Or, what did we get? 904.78 inches cubed. And that is when we are using pi on the calculator. Okay, and let's go ahead and interpret this in the context of the question And basically, this says that after 2 seconds, the volume of the balloon will be approximately 904.32 we can just use that original one, 904.32 cubic inches. And that concludes this section.